We've been throwing a lot of terminology at you, and obviously, Chloe, next year I'll break this up into like 3 separate lessons or whatever. I wasn't sure how much I'd get through in one class. We talked about scalars and vectors. We said in physics, everything is either a scalar or a vector. Scalar has magnitude only. A vector has both magnitude and direction. And one of the things you are going to have to memorize, Emily, is anytime I introduce something new to you, whether it's a scalar or a vector. And I will always tell you anytime I introduce something new to you. Now, we're going to be a little bit sloppy with vectors this year. In Physics 12, we really jump on the directional bandwagon. In Physics 11, typically, we're just going to say for direction, forward we'll call positive, up we'll call positive, right we'll call positive, east we'll call positive, north we'll call positive, unless it makes way more mathematical sense to do it a different way. There will come a point later on this year, Cole, where we're going to be looking at 2 objects attached by a rope, and one is moving up while the other one is moving down. Here, we'll let positive be whichever way makes the math easier, because it doesn't make sense to have one. We've got 2 objects moving in different directions. Which one's correct? Christy, whichever one gives us fewer negatives in our answers. We're going to do that later this year. I introduced to you the notion of speed versus velocity. Speed is a scalar, velocity is a vector. Distance versus displacement. Distance is a scalar. Displacement, your change in position, is a vector. Time is a scalar. And we had just introduced a couple of your first basic equations. Now, these are almost too basic, because in these equations, I'm not letting you speed up or slow down. I'm saying we're going to go at an average speed. Later on, we'll actually be looking at, hey, what happens if you want to speed up or slow down? We'll give you what I call the 4 kinematics equations, the one size fits all, the ring of power 4 equations to bring them all into that work for anything. But for now, we said this: speed was equal to distance over time, change in distance over time. Velocity was equal to displacement over time. And I think, Rihanna, I had just hinted at the notion, and I'm going to flog this to death during the year, and I'm going to push all of you in that direction, that I hate memorizing. And rather than have you memorize, Nick, how many different variables are there in this equation right here? It's technically 3 equations in one, and you can memorize all 3 different equations. You can memorize this one. You can memorize this one. I'm going to teach you how to look at any one of them and derive the other ones from it, preferably in your head. I'm going to push you that way. It's going to be one of the few times you're going to hear your teacher say, less work. Don't show me your work. Do this in your head whenever possible. Oh, we got a latecomer. Now, physics is more than formulas and plugging in numbers, but it's a place to start and build from. So, let's look at example 7, where we said pause here. A motorist travels 350 kilometers during a 6-hour period. What was his average speed in A, kilometers per hour, and B, meters per second? Tristan, how many parts is this thing asking me to find? There's A and B. Little advice, let's put a little A right there. Leave yourself about 1/3 of the room for part A. We're going to need more room to do part B, and put a little part B right there. I use an approach with students, and we're going to formalize this later, but I'll introduce it to you now, called, don't write this down, DFIC. Don't write that down. In Physics 12, you'll hear me I say to kids, when in doubt, DULP and DFIC. DULP stands for draw a little picture. When in doubt, draw a little picture. And DFIC stands for list your data, find a formula, insert the numbers, and crunch the answers. It's a starting point. It is not actually the end-all, be-all. But here's what I mean by that. I always start out by asking, what are they asking me to find? So part A, what are they asking me to find? I know it says in kilometers per hour, so we'll have to read back a bit further. Hannah, what's this question asking me to find? Average speed. This is what I will do. Now that I know what they've asked me to find, I want to identify that, but I don't want to write out they want me to find the average speed. I tend to abbreviate. So here is my system. You'll see almost all the time in my notes, I go like this. The av equals question mark. Write that down. The other reason I like that, Hannah, is the fact that you've written something down. The question is no longer blank. I've learned over the years kids are more relaxed. They'll do better. It's got the juices flowing in the brain. Then I go back and I look for any numbers or physicsy words. For example, Hannah, I see a 350. See it, see it, see it, see it, see it? What is that? What are the units next to the 350? You know what? That's a distance. I keep reading, Hannah. I see a 6.0. What's that? Which is what out of the variables and the equations right up there? Time. Now, this may seem a little trite, a little easy on this stage, but as we get more difficult, this is still going to be a procedure. Now what I would say is I'm looking for an equation that has a V, a D, and a T in it. There is one. Then I would say it'd be nice if the V was by itself. There is one. I got to scroll up a tiny bit, but that one there. Yes? So now I would say to myself, I'm going to give myself a bit more room here just so I can write large enough for you to see. V equals D over T. You'll notice, Emma, no vector sign because it's speed, so distance. In this case, the distance and the displacement are kind of going to be this. Well, there is no velocity, so we're good. Cole, I think V equals D over T is on your formula sheet. Yeah? Somewhere, I think, second row? Yeah? Ish? First row or second row? Second row. At the beginning of the year, if I give you new equations, I will be giving you all their variations, but within a few weeks, I'm only going to give you one, and I'm going to teach you then, Christy, how to rewrite it to any form that you want in your head. It's a much better place to go to. Hannah, what's the distance? What's the time? What's the average speed? Now you get your calculators out, please. Sorry? 58.33333. Okay. By the way, this 350, how many sig figs? 2. This 6.0, how many sig figs? Not 1, but 2. So technically, how many sig figs should I go to in my final answer? 2. I'm going to say, I'm going to go to 3. I'll go 58.3. Units. Distance was kilometers per, time was hours. The units pop out of the equation. Distance divided by time must be kilometers per hour. Now, kilometers per hour is the speed probably that most of you are the most familiar with, especially in your grade 11 or 12 years as you're getting your driver's license. All of our road speeds are kilometers per hour. That is not the preferred units for physics. The preferred units for physics are meters per second. So we're going to do a unit conversion. B. We want to convert 58.33333 kilometers per hour to meters per second. Did I say we want to do a unit conversion? What's the first thing I'm going to do for a unit conversion? I'm going to write down what they gave me. 58.3 repeating kilometers, and then I yelled at you about don't do a slanty fraction. Clearly make sure what's on the top, what's on the bottom. I need to do two things. I need to get rid of kilometers. I'll do that in a step or two. And I need to get rid of hours and I need to convert kilometers to meters, and I need to convert hours to seconds. Nick, what do you want to do first? Kilometers to meters or hours to seconds? Pick. Where is the kilometers in the original fraction? On the top or on the bottom? So where's going to go my second fraction? And meters is going to go here. The most common mistake I saw on the test, kids said, oh, I'll go to my green sheet. They looked up the K. I think K is 10 to the third. Someone can confirm, but I'm pretty sure it's 10 to the third. And look up. Don't do this, don't do this, don't do this. They put the 10 to the third down there. It does not go where the K is. That K is a 10 to the third in disguise. There's already a 10 to the third down there. It's going to go always where you're missing the metric prefix. Don't memorize top or bottom. It goes where you're missing the metric prefix. If we stopped here, this would give us Meters per hour. Nick, and now I need to get rid of hours. Where is the h in the first fraction? On the top or on the bottom? Where is it going to go in my next fraction? How many seconds are in an hour? Has anybody spotted the pattern yet? 3,600. It's 60 times 60. We're going to use a shortcut. So I'm going to put seconds right here, and I'm going to say 1 hour is 3,600 seconds. Where is that 3,600, Nick? On the top or on the bottom? So I'm going to divide by that. In other words, now I'll get my calculator out. I think all of you should have 350 divided by 6. You have that number stored on your calculator right now, Rihanna. I'll use that number. I'm not going to use 58.3. I'm not going to use 58.33. I got that stored. I'm going to go answer button times 10 to the third divided by 3,600. And I get 16.2. 0, 3, 7, 16.2. When in doubt, go to 2 or 3 sig figs from now on for the rest of the year. Is that okay, Maggie? V average is 16.2 meters per second. What you are going to have to make sure of is that your units, Oliver, match. If they give you meters, make sure your time is in seconds. If they give you kilometers, we probably want the time in hours for kilometers per hour. I don't think I'll try and trip you up. I take that back. I was going to say I'm not going to try and trip you up on the test. I might once on the test, but I'm not going to try and trip you up over and over and over and over and over. Example 8. The speed of sound is 330 meters per second. It is. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears his echo? We're going to use my DFIC approach until we get good. So the first thing I'm going to ask, I'm going to say to myself, self, what are they asking me to find here? What are they asking me to find here when they say, how long? I heard someone say it. They're right. Time. How long, by the way, is a bad word in English? Because if I say, how long did the game last? That means time. If I say, how long is the table? That means distance. I will use the word how long in your homework to force you to decide whether it refers to time or whether it refers to distance. I will rarely use that phrase on a test because I'm fussier there. So definitely here, this how long, time. Yes? So all of us, let's write down T equals question mark. And now, Matteo, we go through looking for numbers and physics words. Now, you don't yet know what I mean by physics words. You'll learn some in a few days, but you'll hear me say this phrase. Hey, let's go back. We're looking for numbers and physics words. What's the first number that you see? 330. What are the units right next to it? What is that meters per second a measure of? What is that 330? Speed. If there was a direction, velocity, speed. So I'm going to go V equals 330 meters per second. I keep reading. I see a 420. Yes? What's that? What are the units right next to it? Okay. So what is that? Now, you ready? Here's the advanced part of this question. Oh, I like this question. I like this question. I like this question. Cole, why would I say that? Did you hear me say it's going to be on the test? You got to pay attention. You notice this echo question is a nice one because there's a clever, very slight twist to it. And I do like questions that have a clever, very slight twist to it. Look up. This is wrong. For a candy, can anybody tell me why that's wrong? Cole.
Because it's going to go there and back.
You hear it? It's going to go there and back. What do we have to do with this distance? I'm going to be bold and do that in my head. 840. Yes? I also do a quick units check. My speed is meters per second. My distance is in meters. Are my units okay? Yeah? So, I'm looking for an equation that has a t time, a v, and a d in it. There is one, and preferably find the version that has the t by itself. Mateo, which equation is it?
It's
Is it t equals d over v, or is it t equals v over d? Okay. Common mistakes. Kids mix them up. Here we go. By the way, you can do this if you're bored. What? Typically what I do, I'm a physics nerd. If I'm ever somewhere where there's a really good echo, I'll time how long it takes the echo to come back, and I'll calculate d, how far away the mountain is, and then divide that answer by 2. That's really how far away the mountain is. I kind of like to know these things. I'm a nerd. Anytime I see lightning, I know that it takes sound about 3 seconds to travel a kilometer. So as soon as I see lightning, I start counting. And when I hear the thunder, divide by 3, counting once every second, divide the number of seconds by 3. That's how far away the lightning was. I'm a nerd, Brian. I like to know these things. I think my life is a little bit richer because of that. So this is going to be 840 divided by 330. $840 divided by 330. You get 2.54545454. I'll go 2.55. Why wouldn't I round it 2.54? Next, no. What's next to the 4? So is the 4 going to stay a 4 or become a 5? I'm going to take marks off if you don't round off properly. If you just chop off numbers, we call that truncating. If you do that, Maggie, I'll take a half off. Round off properly. I would accept 2.5. I would accept 2.55. If you said 2.54, I'm taking a half off. If you said 2.54 and put the repeating bar above them, I'd smile and say, sure. But I'm going to be fussy. Let's write accurately, okay? Units. Time. Seconds. I think I yelled last time, but I'll say it again. It's really worth memorizing, Tim, what units go with what concepts. It'll cut down on your thinking. Also, what you'll start to do when you get good, Rihanna, I'm saying right now, you're looking for numbers and physics words. You actually just start to look for units. And then you know right away what that quantity is without even reading the rest of the question, which is kind of a nice shortcut way to get there. All right. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel A in kilometers? Let's put a little A right here. What's this question asking me to find? Distance. I'm going to go D equals question mark. Brian, what's that 18? I got to be fussy since there's no direction, technically speed, because it's the scalar version. Sorry, fussy. I'm not going to mark you wrong for saying velocity, but I got to be honest. Since there's no direction attached to it, it's a speed. So V equals I keep reading. Brian, what's that 2.5? Why can't I do this as is? And I can't. Why not? Sorry? My units don't match. I got meters per second, and I got time in hours. One of these has got to go. We can convert V to kilometers per hour, or we can convert time to seconds. Brian, pick. Time to seconds? Okay. So, how do I go from hours to second? Are you ready? And I'm going to do it right in my notes here. I want hours to cancel. Do you remember, Brian? Or you might have got here after we said this. Do you all remember how many seconds are there in an hour? That's worth, in fact, I don't have it memorized. I just know that it's 60 times 60 because 60 minutes, 60 seconds. And I can go 6 times 6 in my head, which is 36. And I add the 2 zeros. So 3,600 seconds. I think I can do this in my head as well. It's going to be 7,200 plus 1,800. 89, no, 9,000 even? Yeah. I can do math in my head with decimals. Okay. Ryan, I'm looking for an equation that has a D, a V, and a T in it, with preferably having the D by itself. There is one. I think it's all in the... Is it all in the second row? Can someone give me a green sheet? I don't have this one memorized. I'm going to look at yours, Mateo. Front page. Now we're on the front page. Yeah, we're in row 2. I think. Yep. The homework is going to be probably all the questions from here, although I might cross a few out. Spot it, Brian? Give you a hint. It's got a D by itself. Now, you ready, Brian? Because you got here late, so you missed my intro. The other place it is right up here in our notes as well. It's this one, which I think I did put on your formula sheet. Did I not? Did I not? Yes? Yeah. Okay. D equals average speed times time, which is going to be average speed 18 times 9,000. Do that one in your head, Mr. Duke. Okay. It's going to be 9,000 plus 7,200. It's going to be 16,200. Double check me. Am I wrong? I missed a zero. 162,000, not 60. I missed a zero. Gah! Forgot to carry a zero. Not 16,200. 162,000. Gah! Duick. Units. You ready, Bri? What is the distance unit that appeared hidden in here? Did we change anything from meter? You know what? This is in meters. We've just done, actually, not part A, part B wanted the answer in meters. Okay. Let's do part A. In kilometers. How am I going to convert this to kilometers? I'm going to write down what they gave me. Now, I'm going to pause. I've done this enough to know that the easy way to go from meters to kilometers is divide by 1,000. I know this is 162 kilometers. And if you can do that, you do not need to use my build-a-chain method. But my point with that build-a-chain method, Nick, is it works for anything on the planet. So if you're ever stuck, it'll bail you out. So I'll do this the long way, but don't feel like you have to do this the long way. If you have a way that works great for you, Rihanna, knock yourself out. I'm going to get meters to cancel. Kilometers on the top. Kilometers is 10 to the 3. The 10 to the 3 goes where the K isn't, where the metric prefix isn't. So it's dividing, and it is 162 kilometers. The other way I could have done this is instead of changing time to seconds, I could have changed meters per second to kilometers per hour. That would have given me part A in kilometers. Then I would have had to convert that to meters for part B. 6 of one, half a dozen of the other. Example 10. You're not going to blurt out an answer. You're going to vote. I'm going to force you to vote by raising your hand. How high you raise your hand is how sure you are of your answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Duick will make fun of me if I don't vote, and Mr. Duick will make fun of you if you don't vote. I will keep track. So here's the statement. It says this. An object can have a positive distance while having a displacement equaling 0. True or false? So you ready? Here's the statement. An object can have a positive distance while having a displacement equaling 0. Who says, I think that's true? 21. Who thinks that's false? We were going to be doing a lot of these. We call these thought experiments. And so then the next step is you can either attack or defend. You can attack the other person's answer as that must be wrong, or you can defend your own answer as that must be right. Someone convince me. Eventually in Physics 12, we move into fancy schmancy proofs with algebra. For now, I'm just going to say, hey, if you can give me an example, that might convince me whether it's true or false. Convince me. Are you convincing me false or true? You voted false, or you... Sorry?
False.
Okay, convince me.
Going back to your demonstration you did when you walk forward
Yep.
and backwards, see your displacement line.
Yep.
If you have a displacement zero, that means you went forward, but you went back the same amount, so you end up at the same place you go. So you can have a distance of positive, you have a distance of the scale.
Let's go see. Let's walk through his argument. So, 1, 2, 3, 4, 5, 6. What's my distance? 6. What's my displacement? Now, if distance was a vector, and if I counted that as negative, you'd be right. If distance is a scalar, we do not count backwards as negative. Distance just keeps adding up and adding up and adding up and adding up and adding up, no matter which way you're traveling. So what's the correct answer? Have I convinced you? Explain. How about 3 steps forward, 3 steps back? That works for me. You gave me an example. That means it must be at least possible. All right. An object can have a positive distance while having a negative displacement. Once again, you're going to vote. Once again, how high you hold your head up is how sure you are of the answer. I'm positive that it's positive. Huh? See how I did that? Nothing? Really? I'm positive. There's a positive in... Nothing. I'm positive. I'm pretty sure. I'm only voting because Mr. Duke's making me. And I will make you vote. You got to have an opinion. So an object can have a positive distance while having a negative displacement. Who says, yeah, true? Nick, what was that?
It's false.
Okay.
No, it's wrong.
Who says false? That's okay. Okay. So we got 3 that said no go. Convince me. Give me an example. What do you think? See what I'm... What? Yeah.
You can take 3 steps forward, 4 steps back.
In fact, you know what? It's exactly what... I'm going to go copy, paste. This is how lazy I am. Ha-ha! There. Done. That would work. Or just start out at 0, and if you do 3 steps backwards, what's your displacement? -3. What's your distance? +3, because distance is a scalar. Yeah? I missed a what? I missed a vote? Like you mean counting up the number of people? Yeah. I was doing a rough count. Did somebody vote maybe? Sometimes? Eventually, we'll have like 4 or 5 options. We'll really build into some. By the way, I don't mind the fact that Nick said I'm voting false, but I think it's wrong. One of the things we do often in math or in physics is called a proof by contradiction. We say, well, let's assume that it's true, or let's assume that it's false, and if we arrive at a logical contradiction, we know our initial statement was the wrong one. All right. Example 12. An object can have 0 distance while having a positive displacement. Oh. Ooh. I don't know. Think. For your own thinking. An object can have 0 distance while having a positive displacement. Ooh. True? True. False? Happy, Dylan? Didn't miss any votes that time. Convince me. Can you, by the way, for you to be right, all you have to do is think of a single solitary example that that's the case. There's a famous story. It's a math riddle, math problem. It says this. A physicist, a mathematician, and a statistician are walking in Australia. And off on the horizon, they see a sheep walking parallel to them, They see the side of the sheep, and it's black. The statistician says, oh, look at that. There's a black sheep in Australia. We can conclude all sheep in Australia are black, because statistics likes to make broad conclusions. The mathematician says, no. We can't conclude that. All we conclude is that there are sheep in Australia, some of which are black. The physicist says, no. We can't even conclude that. All we conclude is that there are sheep in Australia, and there's one sheep that has at least one side of it that's black. All you got to do is find a counterexample. What we're saying is, if you can break things down and keep going down that rabbit hole further and further and further, so convince me. You might be right. I think you're wrong, but maybe not. Can anybody think of a way to have no distance and have a positive displacement? By the way, if you have zero distance, what's your change in position as a number?
0.
So the real question you're asking is 0 a positive number or not? Ooh, we just got really deep. Is 0 positive?
It's neutral.
Is it?
Yeah. I think the object is we kept the objects on not 0 as a displacement.
So it depends where you decide the position might be. Okay, can you give me an example of a position that I could start out at such that I would have 0 distance and have 0, instead of the word displacement, I'm going to say change in position. That's what displacement was defined as. I'm still not coming up with one. So I think I'm going to go, okay, where it says explain this time, false, I can't come up with an example that makes it true. This comic is from the comic strip called Foxtrot. I love Foxtrot. The author, Bill Ammond, actually has a physics degree. When he was in university, he was doodling all the time in his books, and some of his friends said, these are funny, you should publish them. So he makes a living writing the comic strip Foxtrot. And in the comic strip Foxtrot, the youngest brother, Jason, is a nerd with whom I identify. So Jason and his older brother, Peter, are playing football. And Jason says this, okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit with the ball. Peter does some calculating. Won't I be right back where I started? Jason says, I can't throw very far. Peter says, okay, here's a new play. And Jason says, I never get to be quarterback. For the record, I won't do it today, but I have taken classes out to the football field, and we have run this play, and you do end up back where you started from. What I love about Foxtrot is any physics that he brings in, he's meticulous. He makes darn sure that it's correct. So you ready? What distance will Peter run in order to complete this play? Well, distance is a scalar. It's going to be 40 plus 20 plus 25 plus 30 plus 30 plus 10 plus 15 plus 20 plus 50. Let me make sure I didn't miss anything. 40 plus 20 plus 25 plus 30 plus 30 plus 10. By the way, you see what I'm doing? I'm just looking for numbers the same way I told you. It's a good trick. Plus 15 plus 20 plus 50. Well, I can add this in my head. Easy. 60 plus 60 is 120. Plus another 60 is 180. 200. 235? Double check me. 235? Yes? No? Am I wrong? I might be wrong. 60 and 60 is 120. There's another 60 there, 180. Add 20, that's 200. And then I add 15. And 240. Sorry, 240. Yes? Forgot to carry a 1. Jeez, do it. Units. Yards, and that's why Y is reserved for yards and not year. Hey, everyone. What will Peter's displacement with the vector symbol be? Exactly how big? Yep. That's really the difference between distance and displacement. Race cars, like the Indy 500, if they were displacement, would be called the Indy 0. Right? You start at the start line, you end at the start line. Same place you started. 500 laps later, but your displacement is 0. In fact, technically, any race that you start and end at the same place once around the track, your displacement is 0. What's your homework? Number 1. 2 is good. In number 2, each of these grids is 1 kilometer. So that's how you can figure out distances. Each little line is 1 kilometer. And I think I shrunk it down, but I think you folks can read it. I hope. 3 is good. When I photocopied this, it didn't show up very good. That's the initial, and that's the final. Is that in your copy? I handwrote it. The first year I did this, we couldn't read the subscripts, which didn't do much good because I use subscripts all the time. 4 is good. 5 is good. I might assign most of these. Yep, 6 is good. 7 is good. 8 is good. 9 is good. Private jet. I wish. 10 is cool because it's light and the moon. Number 10, Cole, is just like your echo question, except instead of sound, we're bouncing light off the moon and back. This is, if you ever listen to the old astronaut radio messages, it's about 1.5 seconds-ish to get to the moon, and that's why Houston, beep, come in, Apollo. Beep, there's about 1.5 seconds delay in between each statement. If we do ever send something to Mars, the big issue with on Mars, it's about a 7.5-minute trip there and a 7.5-minute trip back for the radio waves, so it's about a 13-minute delay. This is why all of the rovers that we send to Mars, we don't just design a remote control rover. A remote control rover would work great on the moon, probably. There'd be about 1.5 seconds or a 3-second delay, but you could manage that. But a 13-minute delay, if you saw a cliff coming up and 13 minutes later you told the rover to stop, it's already over the cliff. Oh, what the heck? Let's try that again, Mr. Dewick. Oh, answers. That was a little weird. They just kind of vanished all of a sudden. No, there they are. Answers. Hey, if you finish this, you have no homework for the long weekend. Next class, we're doing the fun lab. Come prepared to yell and make noise. Mateo says, I'm good at that. Okay, there you go.